stop typing, eyes on the screen. We are now doing script 7a, export. Earth Engine is a completely open system. You can download all your process data at any point in your script. So whatever you've done, you say, I'm done, I want to download the result. You can download your images as GeoTIFF files. You can download your vectors as shape files or GeoJSON or CSV files. So that means that you can now do your analysis. When you have your results, you can download it, and you can take it into another software you want. So let's see how do we take this and download this data. To do this outside of Earth Engine, it's still a lot of hard work. It takes a lot of computation. You did this in Earth Engine, and let's say I want to take these images and do some analysis in my R code, or I need to do this in ArcGIS. So we can download this and use this. Let's see how the download works in Earth Engine. We have our clipped image. Let me print the clipped image here. This is an image containing 16 bands. Okay. We have band 1 through band 12. These are the spectral bands. So we have the different wavelengths, capture reflectance here. There are 13 bands in the Sentinel-2 data. There are also some QA bands. The QA bands contain information on clouds and other information about each pixel. You can choose to download all of this or a subset of this. First, let's say I want to just download certain bands. I want to download just RGB bands. Okay. So I'm going to create a new image. I'm going to just name this image as export image. Take my clipped image and just say select. So select is a function that allows you to select bands. This can take different kinds of arguments. You can select, say, one single band. So I can say select B4. You can see we had a 16-band image. We ended up with one band image. Right? It just selected the band 4. The select function can also take a list of bands. So you can say, give me band 4, band 3, band 2, and close square bracket. You get a list. So you can see I have 3 bands, and I can download that. Okay, so you can select the subset of bands you want. What if you wanted all the bands which are from B1 through B12? You say, I don't want QA bands, but I just want the B bands. So the select function can also take a pattern that it can match. So I can say, give me all bands matching this pattern, B dot star. That means anything starting with B followed by anything else. And you can see now I have 13 bands, which are only the B bands. Right? So you can use the select function to select a subset of bands that you want for your analysis. Select and filter are quite confusing. Filter will work on image collections to select images. Select function will allow you to select the bands from an image. Okay, so they are similar, but they do very different things. For now, let's just say I want to download 4, 3, and 2. I want to download these 3 bands. So let's export. Let's go to docs. I search for export. Earth Engine can export images. So you can export images. You can export tables. So if you have a feature collection you want to export, you can export it as a table. You can export a video. If you have an image collection with multiple images, it'll create this animation, which you can export. It exports something called a map, which is you can create a tiled map if you want to publish on the web, etc. But most of the time, you want to just export an image. So we have an image. You can see when I print this, this is an image with 3 bands. So I can use this export image functions. There are 3 functions here. Export image to asset. This function will run an export and put the image back into Earth Engine. Okay. All of you have storage that is tied to your account. All of you get 250 gigabytes of storage. If I go to assets, these are the assets that I have. I can choose to say, I have my composite, I've clipped it, I will export it back into my account as an image. The advantage of this is that when I run this script, it has to compute this image from Sentinel to collection, right? It has to run the whole computation. Versus if I export it, it's already computed. It's just an image. So if I want to share this with my colleague, I say, I'm done with the part 1 of the project. Here are some images I generated. You can take that and start your analysis. Right? Also, if you have an analysis that is very long and complex, you say, I have a 1,000-line script that's doing everything from source to all the way to some classification and machine learning. It helps to just break down your project into multiple parts. I do the part 1, create a composite, export it as an asset. Part 2, I'll import it, and I'll do the second part. That means in the second part, I don't have to run the whole first part. It's already done. Right? So export, highly recommended. All my projects will take shape of break it down into logical steps, export the results as an asset, and import it. There's export image to cloud storage. Google has this product called Cloud Storage, which is a Google Cloud product where you can store some data. So if you're using Google Cloud and you want to export your data to there, you can use that. This is not a free product, it's a paid product, so you'll incur charges for the storage. The advantage of cloud storage is that you only get charged for the amount of data you use for the duration that you use. So you say, I want to export 1 terabyte of image. You export it, image gets created, you download it after 10 minutes, you'll get charged for using 1 terabyte for 10 minutes. Right? So it's great for very large exports where you can export it, download it, delete the data, don't forget to delete it, otherwise you'll get charged for it. Right? There's a saying in cloud computing that you don't pay for what you use, you pay for what you forget to turn off. Right? So, but cloud storage is great if you're doing countrywide exports, if you don't have enough space in your drive. But the one that you'll use a lot is the drive. Everybody has a Google Drive, 15 GB of free storage. Many of you might have more storage, so you can export it to the drive. So let's use this. This is a very scary looking function. Right? Some 20 parameters. The first time I encountered this, I just closed Earth Engine. It's like, I don't want to write this function just to download my image. Right? I'm going to teach you some tricks that will make these functions less scary, and you'll learn how to fill these parameters of those this very long functions very easily. So let's learn how to write these functions. I'm going to teach you this thing called autocomplete. Code editor has this thing called autocomplete, where you can complete the function names and parameters automatically. The keyboard shortcut is Control plus space. So let's say I write few words of my function. It can autocomplete function names as well as parameters. So I can do Control space, and it'll give me this pop-up saying that you matched some of those function names. You can use your arrow keys. You can select this. So export image. You can now select this, and I can do this. So now, just type a few characters, Control space to autocomplete. The cool part is, once you autocomplete, you can press Control space again. It'll fill all the parameters that is required. So you don't have to go to the documentation. Right? So you can see it filled all the parameters of my function. One more time. So you type few letters, use your arrow keys. Once you're done, Control space to autofill everything again. And now you have all the parameters. Now you can just start filling those parameters. If you start filling the parameters, it says what image you want to export. You'll say, I want clipped image. What's the description, and so on. Many of these parameters are optional. So if you say, I don't want to give a description, then you'll have to skip it, and you have to give null, etc. So instead of that, Earth Engine gives you a much better way, saying that if you want to fill all these parameters, just give them as a dictionary. So instead of giving this each parameter, we start a dictionary here, curly brackets, and then we give the parameters. So now we give the dictionaries are key value pairs. So we say, what image you want to export? So we say we want the export image. Next parameter, description. Description is what will appear in your code editor that this export is running. Sometimes export might take 5 minutes, 10 minutes. If you're exporting the entire world, it might take 5 hours. So you want to know what export is running. So it's just a description that you can specify. I'm going to enter a description. The description doesn't take spaces. So you can use underscore, but do not have spaces in your description. Folder. By default, when you run this function, it's going to create the file at the root of your Google Drive. And it'll create the file that you want. I don't like my drive to be cluttered, so I always export it to a specific folder in my drive so that it just goes there. I like to use a folder named Earth Engine. You can use whatever folder name. Right? If the folder doesn't exist, it's going to create one for you in your Google Drive. File name prefix, when you export an image, the suffix will be .tiff. It's a geotiff file. So the prefix is the file name, what you want. So let's give the file name Composite. Dimensions you typically don't give. It's not required, so we skip the dimensions parameter. Region, what region you want to export. This is a parameter that you should never forget. You always need to give the region parameter, even if you have clipped the image. You can see the export image is already clipped. We have already clipped it, but it's still you need to give the region. So I will say export the region in this geometry. If you forget this, Earth Engine will export the part that is visible on your map when you click the run button. Many of my students write to me, my export is a rectangle, and I don't even open the script. I said, you forgot the region parameter, right? Because you can see if I export it, I'll get this rectangle. Earth Engine says I will export this. In the user forum, many people write, I started export of my city, it's running after 5 days. And they say, you forgot the region, you were zoomed out the whole world, it's exporting the whole world, right? So always give region parameters, you should never forget that. Scale, what is the resolution that you want to export the data? The way Earth Engine works is you can give the scale and a projection, and your output will be in that projection. So you say, I want my output to be in UTM projection at 10 meter per pixel resolution. If you specify this, Earth Engine will say, oh, I need to create a composite at 10 meter in this projection. It'll go back and reproject all your source images into that projection and create a composite there. So in Earth Engine, you typically don't deal with projections at all. When you want your output, you specify what projection you want your output to be generated in. Earth Engine will just reproject everything. And that's one of the biggest innovations that Earth Engine came up that helps in a lot of data processing. When you want to fuse data from different sources, you don't worry about projections. Earth Engine will do all of that for you. Otherwise, in your traditional remote sensing, the first thing you do is resample and reproject your data. And that's your first step. In Earth Engine, you don't do this. It'll take care of it for you. Scale is the resolution, the pixel resolution. So you come to the dataset description. What bands are we exporting? We are exporting 4, 3, and 2. Those are all 10 meter resolution. So we can export this and say, I want my output to be having 10 meter per pixel resolution. The scale is always in meters. Even if your data you uploaded is in degrees or whatever, scale will always be in meters. This question.
So there in Sentinel-2, you have bands that there are 60 meters and then others that are 10 meters. What do you do there?
Yeah, so let's say I'm exporting all B.star, right? And I have bands which are now different resolutions. I have some 20 meters, some 60 meters. What do I give here? If I give 10 meters, all my 20 and 60 meter bands will be upsampled to 10 meters. They'll be resampled to 10 meters. I say I want my output at 20 meters. My 10 meter bands will be resampled to 20 meters. Right? So you choose what resolution you want your export in.
So you can define it as 30.
Yeah, and everything will be resampled to that. CRS, you can specify CRS if you have, for example, an EPSG code for the projection that you want to use. You can give this. Like this is the code for the city of this region we are working in. If you skip it, it'll take the projection of the first band of the image and use that. Right? So we don't want to give that. So we can say skip the CRS. Max pixels. This is another one of the tricky parameters. Earth Engine has some guardrails to make sure that you don't accidentally do crazy things as a new user. It says the maximum pixel you can export by default is 10 million. If your image has more than 10 million pixels, it's going to stop your export. And you'll get an error. Image too many pixels. And you might say 10 million is good enough. But if you do even a city like this, 13 bands at 10 meter resolution, you can easily exceed the 10 million. And many times you'll get this error. And that error doesn't mean that you cannot export more than 10 million pixels. It just says, by default, to stop your drive getting accidentally full and having things, it'll stop your export. So now, after taking this workshop, you know what you're doing. So you don't need that guardrails. You can say max pixels. I usually set it to like a large number, 1 followed by 10 zeros. Right? You'll never get this max pixels error. Rest, you don't need. I can skip this. Close my dictionary, and I'm done. Right? So we filled these parameters of my very complex looking export function. And now when I run the code, it'll say there's a task pending for you. The task tab will light up, and it says there's an unsubmitted task. The export is not yet started. It's waiting for a confirmation. Click run. One more confirmation. This is what you're doing. Are you sure? And then you click run. Once the gear starts spinning, that means my export has started. At this point, I can close Earth Engine browser. I can shut my computer down, and the export will still keep running. And once the export finishes, a new file will magically appear in my drive once the export is done.
Hello. So sometimes when I do export, I see at my drive that I have 3 exports because of size issues. And I was wondering if there is a way to work around it without changing the scale.
Yeah, so again, to think about how Earth Engine works, if you say I want to export the entire country at 10-meter resolution, Earth Engine will do the processing. Everything is being done at different machines. Each machine is doing a small part. And then it says, oh, you want one file for the entire country. So I want to combine everything and create this one file. Now that means I want to create one file. It has to be done by one machine. And that might slow down your system. So Earth Engine says, to allow for parallel processing, each export will be chopped into maximum size of 10,000 by 10,000 pixels. So if you have a very large region, you can just start the export, but you'll get multiple files, things like row 1, column 1, row 1, column 2, row 1, column 3. Right? You just chop your data into separate chunks so that they can be processed by different machines. And that just speeds up the processing. You'll have to download and then mosaic it using GDAL or QGIS or some other software. But that's a common question that you get. But again, the way Earth Engine is just trying to be helpful to make it speed up. Otherwise, it'll take much longer for a single machine to do that.
But as you were pointing out too, sometimes if you change the scale, so like, and it also kind of goes back to the earlier one too about that max pixels and the scale, because he's exporting it at this maximum resolution of 10 meters, you might find it runs quicker, or also you won't get multiple clips of the image if you say go on 30 or 60 or a coarser scale. But again, that might not be what you want. You probably want it at 10. Therefore, you have to deal with the issue of now you have to put it back together.
Yeah, and scale is something that, again, in desktop processing, you never have to deal with scale. It's whatever it is. In Earth Engine, you have the flexibility. By default, you always use the resolution. But you say, OK, I just want a low-res preview of my data. I can export it as 1 kilometer, and I'll get a small image. And it'll go much faster. So you have that option. But most users, whenever you encounter the scale parameter, it's always the pixel resolution of your data. Every dataset description in Earth Engine has the resolution in meters. Whatever dataset you go, so for example, let's say I'm working with some precipitation data. This one is a 0.25 degrees resolution data. And you say, well, I want to export this, you'll have to get a scale parameter. So what's the scale in meters for 0.25 degrees? Well, you come here, go to the bands, it'll always give you this resolution in meters. Right? Every page of dataset has this resolution in meters. So you'll go and find and use that value as your scale value.
Sorry, quick question. You may have answered this, and I'm sorry if I missed it. But so in that list of parameters, they're optional. So if I don't specify the scale, does it default to either the maximum or the minimum scale of the sets of images I've included?
Scale. Resolution in meters defaults to 1 kilometer.
OK, thank you.
Yeah.
How does this apply when you're looking at an image is being visualized?
That's a great question. What are we looking at? At what resolution? Let me inspect this. If I inspect this and expand this point, it says scale. 611 meters. So right now what you're visualizing is your composite at 600 meter per pixel resolution. That's what Earth Engine is showing you. If I zoom in a bit more and inspect it again, it says you are now at 150 meters per pixel scale. And you can zoom in and you can see this. And this is also the reason Earth Engine can do this processing faster, because right now it says I want to display this composite at 150 meters per pixel. It's going to create this composite at 150 meter scale per pixel. It's not going to create that at 10 meters per pixel. It'll say, I'm displaying it. When you're ready to export, you specify whatever scale, and then I'll run your analysis at whatever scale you used. Yeah.
Sorry, can you force it to display a scale?
You can, but not recommended. So let's say you can force it to display it at 10 meter. That means if I zoom out, it has to compute the whole thing at 10 meter. There'll be millions of pixels, and your browser might slow down or not display that. So there's a function called Reproject, which some people use to force your output at a certain scale. Do not do this. Right? If you want to visualize your result at a specific scale, export. This just gives you much better experience rather than forcing Earth Engine to display something at a specific scale. It doesn't result in a good experience. Yeah.
The region parameter has to be always a vector?
It has to be a geometry. Some geometry, polygon, bounding box.
Okay, but if I have a raster,
then you say, if you have an image, you say image.geometry, which will give you the bounding box of the image.
Okay, thank you.
Another question over here.
So along the lines of reproject, I use reproject in the export statement. It's super slow. But computationally, what is occurring when it's running? Is that nearest neighbor or like an unfold reprojection or some sort of like edgewise upscaling algorithm?
Yeah, good question. When you do reproject, what kind of resampling reprojection is doing? It's a good time to look at the user guide. Let's go to the user guide. When I use other software, QGIS, ArcGIS, other things, I typically don't look at the documentation. When I have some problem, I just search into this. Earth Engine is an exception. Earth Engine documentation is really good. Justin, who maintains the documentation, does a phenomenal job. You have so much information, very high quality information. So this would going to be a good starting point. When you have questions, search here. Instead of the internet, you get much better result. So resampling. By default, resample is done using nearest neighbor. You can say dot resample by linear or by cubic to force your resampling in a particular projection. So you just say, before exporting, you say, I want to do by cubic. You'll say clipped or image.resample by cubic. And when you export it, it'll use that to resample your pixels to a particular size. And again, reproject is never a good idea. I've yet to find a good reason to use a reproject in your code. The only reason you'll use reproject is when you are trying to combine data set of very different pixel sizes. Let's say you are trying to combine Landsat and MODIS in a single analysis. Landsat pixels are 30 meters, MODIS pixels are 500 meters, and you want to combine those two, you'll have to say, I will take all the Landsat pixels and reduce resolution. So I will combine all the Landsat pixels within a single MODIS pixel and create this larger pixel. So there is this function called reduce resolution, which is used to reduce the resolution of a high-res image to compare with the low-res image. And you use this function, there's a reproject function here. And again, you do this, it's a quite computationally intensive. You export your result, but you never kind of display this thing. But that's the only place where you should use projection and reproject, where you are working with very diverse pixel sizes and you want to match them together.
One last question.
Yeah.
This is kind of separate from what I probably should have brought up earlier. Can you talk about when you would use a dot reducer?
It's coming up next,
Oh.
in the next part. Dot.
And you're going to explain why, too.
Yeah, dot reduce versus dot median, right? Yeah, I'll explain.
How about when you want to like concatenate two images, like label and data, and they have different coordinate system? You have to reproject, right?
No, that's the beauty of Earth Engine. Let's say I want to do some data fusion, Sentinel-1 and Sentinel-2. I have two images. I can say Sentinel-2 dot add bands Sentinel-1, and when I export, I say 10-meter resolution, this projection. Earth Engine will do the reprojection for me.
And it reprojects to the first.
Whatever you specify. You say when I'm exporting, I say this is the pixel size and this is the CRS. It'll reproject all of those bands to that.
Another question, there's an option for export that kind of creates patches of images. Do you recommend to use it?
Yeah, so there is a format called TF record where you can export small image patches that is for deep learning. So when you're building a deep learning model, the deep learning models typically require small image patches of 256 pixels or 156 pixels. So if you do TF record, you have an option to specify the patch size.
Thanks.
I just wanted to add that explicit casting is sometimes useful also, right, for export. I was wondering if you want to elaborate on that piece a little bit, because a lot of people will download a float image and then it won't render because it'll look all black. Because
yeah, so let's say I want to print my export image. The type of the pixels here are double. There's a floating point numbers. Remember we had an integer image and we did some median compositing. Now we have a floating point image. So when you download it, it'll download as a floating point number. You can just say, I want to convert it into an int image. So it'll convert that into an integer. Again, if you do this if you need it, most of the time it's not needed. I think most software is able to do it. I'm going to show you this data in QGIS now. It renders fine without any issue. Right, so let's see the export. So my export finished. It took 7 minutes for Earth Engine to create this data. Earth Engine now displays the cost. It costed Earth Engine 1787 EECU seconds, Earth Engine compute unit seconds, and you can look up the documentation on what that means for dollar amounts. So you know what that is. If you're a free user, it's free, but again, if you want to know how much it costs, you can use this. You can say open in Drive. So this is my Earth Engine folder, and I have my composite, which I just exported. You can see it's 150 megabytes in size, which I exported, and now I can just download this to my computer. Okay, so it's downloading to my computer, and I can show this in QGIS. Again, there are so many pixels, QGIS is taking a while to render this, right? It's 10 meters per pixel, but you can see the image that we downloaded. And again, if you see this image looks slightly different in QGIS than here, because QGIS is visualizing using their own parameters. If I just do 0 to 3000, it'll look the same because it's just visualizing that images in the same visualization parameters. Right? So it looks the same now in QGIS. But now we have the raw pixel values downloaded and as a GeoTIFF file on my computer that I can use. All right, let's do the exercise. 7C. I've already written the export function. I didn't write my own export function till 2 years after I learned Earth Engine. So do not expect to write your own export function. Feel free to copy paste it. So here you already have it. The exercise is change your region to your own selected region. Run the code, which will start the export. Go and start the export. And once the export starts, it'll create a new file in your Google Drive. So try out the 7C. exercise is to change the filters to be your own regions, whatever you've been using. Run this. It should give you a new task here. Make sure you click run and start the export. Depending on the size of the region, it might take anywhere from 5 to 10, 15 minutes. And remember, this is a shared compute. So if there are a lot of users in the system, many people say, yesterday I exported in 5 minutes. Today it took 10 minutes. Why? Because there's more people using the resources. So again, it's not, depends on the system. Pro tip, at least I've seen, it's good to start export when US is sleeping. That usually goes much faster.
Talking about that with somebody yesterday. It was like, said, yeah, my experience also around midnight in the US is a good time to do some of these exports. And I guess like another thing, have multiple accounts.
Excuse me, I have another question about the composite. I use the median composite. This one, but it's so different skin.
Yeah, this is because of the BRDF effect. If you look up the BRDF effect, because the way the sensors are done. So two solutions. I've seen this. I'll give you two solutions. One is have more images. If you expand the time period, the more images you have, this effect will go away because it will cancel out. Second, there is a script available to do the BRDF correction. And you apply the BRDF correction, it also will remove those effects of that. So I'm going to add the code for BRDF correction in the slide deck, in the last slide. Right? I have the code, so you can do this. But most people, I've seen this happen. You have more images, maybe expand from a few months to a year, and you have enough images, the effect will cancel out. It's just because your landscape is illuminated differently. One time it's like this, one time it's like this. So two different scenes have this kind of effect of that.
So we try to train the depth, like, for example,
Make it bigger range.
April, this year, or we could compare in April, but last year, something like that, maybe the same or similar. When they are different picture, get different.
So there's a question on when you are trying to work with large areas, sometimes you'll see the striping effects when you do a composite. And this is due to this effect called BRDF effect. It's just your landscape is illuminated at different angles. And when you combine those two images, they are different. So in your slide deck, I'm going to add one more slide at the end with notes. I have code that somebody has written for BRDF correction. So I'll put that so you can access that. All right, everybody's export is running. Some tips on the export. You'll be doing a lot of exports. If you are doing some research or you're trying out different things, typically in a GIS settings, you'll have, you'll name your files. I did something, my export is, composite underscore median underscore try1. And you change something and you'll say underscore try2. And they'll say underscore try2 final, and then final, right? If you're doing this, you can, you create files and describe the file of how you created that file to get some idea. And when you're doing some machine learning model, you have to try a lot of different parameters. And you say, I'll export everything, pick the one that works the best. And let's say you exported some 100 combinations and you found one image, and then you have to guess, do I remember how I generated this image? One tip I have is, when you want to share your script in Earth Engine, you have this button here. So let's say I have the script, I want to share this with a colleague or with somebody for help. I can click this button called Get Link. It gives you a URL that looks like this, code.earthengine.google.com/ this long number. What Earth Engine did is it encoded your code and into this URL. That means I can send a URL to somebody. I can send this URL to you, and if you open this, you'll see exactly what I typed in my code editor. It's like a static snapshot. If I modify my script afterwards, it won't change. It's just a snapshot in time that this was my code. So if you have some errors in your code and if you ask my help, click get link, send me a code, and I'll say, oh, you made a mistake here. You forgot a semicolon. And I add a semicolon, do something, I'll click get link again, send you the link, you can open this. So this is a feature that Earth Engine has, super helpful for sharing code. Now what you can do is, if you're exporting the data, just before you click run, you say, I'm ready to export, just before you click run, you can click this get link, copy this last part of the URL. Okay. So I generated the link which has a code, and now I'll name my export as S2 composite underscore this. And let me run this. Well, let me run this at, say, 100 scale, so it just goes faster, and I'll show you the result. So it's going to create a file called S2 composite with this long number .tiff in my drive. And I can keep doing this. I open my file and say, oh, this looks good. How did I generate this file? Well, the code to generate this file is already part of the file name. I can just take this and say, I want to know how I've generated this file, and just go to code.earthengine.google.com, paste this, and I have the code of how I've generated those files. If you get used to doing this, you'll thank me 6 months later when you discover a file. It's like, this looks so good, I forgot how I generated this. So the code to generate the file is in the file name itself. Yes?
Is there a time limit on how long that URL will be good?
Yeah, so the URL lives forever. I think the URLs even from 10 years ago are still in the system. So Earth Engine teams try to maintain this as long as possible. That also brings the question, what if you're working on a super secret project and you clicked get link and shared it to the wrong email? It's like, what happens now? My code is gone. Earth Engine has this thing. If you come here, it says manage links, and you can go and delete that. So I had generated this link, you can go and delete that. But unless you delete that manually, it is available for everybody to use. And that also is great. I have seen a lot of papers where they include the code. So it's good for reproducibility of your science, where you can reproduce any analysis just with the code link. So super helpful. My export finished, so let's see. You can see I have this TIFF file here. The file name itself has the code to generate that file. Like, super cool. I think that's something that Earth Engine team worked really hard to kind of have this system for reproducibility. Any other questions on export? Yeah.
So is it the same procedures?
Yeah, you are exporting to cloud storage bucket. You create your bucket, and in your cloud storage, you just give the bucket name. Here.
The name, okay.
Yeah.
All right. Thanks.
Okay, we are done with this module. The module was designed to help you discover data, do some processing, filters, composites, export. You should have good idea of how Earth Engine system works. Word of warning, Earth Engine is a steep learning curve. If you go back excited today at home and start writing code, you might say, oh, I don't really know how to work with the system. Give yourself some time. I would say it takes about 6 months of working with the system to get comfortable, where you can just open up a code editor and start typing. Before that, it's okay to copy paste the code, find examples, modified. The main skill that you want to learn is how to modify the code, like how to get the code, change few things to make it work for your system. But again, if you start using this for exporting data like this, it'll save you a lot of time. And then the next module, which will start, will say, I want to actually do some processing. I want to compute index. I want to create some time series analysis. So we'll do that in the next module.